This is the experiment A. It's radioactivity. I'm just going to write that, although the title is longer. It's radioactivity and absorption of radioactive particles, but you can read that out of everybody should have one of the handouts. Okay. First things, become familiar with the Geiger meter tube. Oh, first thing on your book, you need to put partners and purpose and partners equipment. Which is first?
Focus.
And then you write that down, and you'll repeat this on each part and equipment. And then you list the equipment, and we're ready to go. Now, the equipment, let's do part number A. No, part A, 1A. Part 1, you have familiarization. And on that, you have part A. Actually, familiarization, you should do the purpose and procedure. So that's for part 1. Then for part 1A is actually getting familiar with it. And then here's the Geiger tube. Here's the counter. This one has Geiger-Müller and sink. You put the Geiger-Müller tube in the Geiger-Müller tube section. You get one of the power supplies, and when you put the stuff up, you put the power supply back over there. You do not plug it in yet. There's a power supply hole right there. And you're supposed to get familiar with this. You draw a picture of the situation over here in your book. You have the Geiger tube and the tray holder and the connection from the Geiger tube to the back and the connection over here to the power supply. You draw that picture, you draw this more carefully. And on this one it shows the display up here at the top. And then you've got 3 things here. And on the back, you've got an on-off switch. So you've got the equipment described, and here you've got the equipment displayed, what's on here. You become familiar with these things. This says count, this says stop, reset, display select, down, and up. On part B, 1B is the set the high voltage, is what it says. This is gamma source. Here's the tray. We put the gamma source in the tray. We put the tray, I'm going to put it up fairly close to the top so we'll have a fairly active count. So now there's radiation hitting the Geiger tube. We plug this in. We turn it on. This has here's the various things we're going to. This is display select. I'm going to set the high voltage. I click it once, it goes to time. I click it again, it goes to rate. I click it again, it goes to high voltage. It says it's at 0, which it should be. Then I jack the voltage up. We try going up. There's 40, 60, 80 volts, 100, 20, 40, 60, 80 volts, 100, 200, 300, 400, 500, 600. Now then we try to find out if it's counting. We put this on the timer. We want to set the time at 5 seconds for this first part. 1, 2, 3, 4, 5 seconds. And then we go to counts. So now it should be ready to count. Right now the light's on stop. I hit the count button and we're not getting anything. Okay, go back to voltage. High voltage will go up. It says the next one to try is 750. We don't get 750, but we get 760. And then we go back to count and hit the reset and then count again. We're starting to get a few little counts there. Not very much. Let's try select high voltage up 700, 800. Let's try it again. Reset, count. Now you're getting a much better count here at 800 volts. We might want to stop there. The instructions say try 900. You don't want to get too high voltage or you'll destroy the tube. Let's displace, reset, select, going up to voltage. 900. All right, reset, count. Now it's counting real good right now, so we don't go any higher on this one. Got up to 99. Reset, do it again. 94, 90. Oh, it's 94, okay. And we'll try it again, just to see that it's working properly. Reset, count again. So it fluctuates a little bit about that number. It better fluctuate. If you get the same number every time, there's something wrong. Okay? So that's how you get this. You see how you can set the time. If you want to set this, let's reset that. Go to set the time for 60 seconds. We go up. There's 1 minute. And I'm not going to count that. It's going to take a whole minute to do it. Okay, I can drop it down to 10 seconds. Ten seconds, and then it did get twice the count. You should get about twice the value. Reset, count. It should be 20 seconds. So you see, just to get a minute, you can put it on a minute. If you want 2 minutes, you can put it on 120 seconds. So that's the way you get this one operating. All right, we will turn that one off, unplug it, and it's secure. Now this one only has the one Geiger tube, so it won't go. You don't have to worry about getting it in the wrong one. The power supply right there. Need a radioactive source. We got it set up. We can now plug it in. The on button is back here in the back. It says display off, and we want to first set the high voltage. So we rotate this around to high voltage. We're over there, we had to punch buttons to get it to the high voltage. It's at 0 high voltage. And we go up 25, 50, 75, Well, come on. 100. You don't want to get this one up to 900 volts because this tube is set to run at, in fact, you might watch this little thing right here and it will show you when we're getting, see, it's just barely starting at 525. 550, it's starting to count. And so we go ahead and take this up to 600 to get in the middle of the plateau. Okay, we're at 600 volts. We now put this over to, rotate over to counts. No, we want to put it on time. We want 5 seconds. So I've got this on the time. We want to set the time to 5 seconds, so we go up. 1, 2, 3, 4, 5. There's 5 seconds. We now go over to counts. And let's see, it should be counting pretty good right now. There it goes. Full blast. There's a 5-second count. Here we're getting 158. Over there we were getting about 100. So there's slight difference in some of the sensitivity of the tube, etc. We can reset, repeat it. $162, reset, repeat. $148, etc. So we got the tube working, we got the voltage set, we know how to do the timer, etc. So we set, and to set the time to 60 seconds, you pull this over here. Looks like I got to reset all the way up. I'm surprised that doesn't show 5 seconds. It did. 6, 7, 8, 9, 10. We could take it on up to 60 seconds. Reset. We're on counts. It should get, last time it was 150, about 300 counts in 10 seconds. There's 295. Any questions on how to operate it? To be safe, we ought to put this back at high voltage and drop the voltage down to 0. It should go to 0 when it sets in, but it's smarter to take it all the way down so that you know it's 0 when you turn it off. Okay, so then we put this back over to display off, and then we can turn the whole thing off. Here's the power. Here's the absorbers. You have some plastic absorbers, and here it gives the thickness, effectively the thickness of the material. This is plastic, and this is in milligrams per square centimeter. You normally plot it in grams per square centimeter. So this is very low. The plastic here is E, 102 milligrams per square centimeter. Your instructions gives you more detail on that. Here we have aluminum, H, 161. Here we have thicker aluminum, P. Over here we have lead, and it tells you what they are. And so one of the plots is absorption. You put different absorbers in there, and when you do, you don't do all of them. You do about some here, 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 here. Okay. Of 1 minute count, and then you average the result. 1D, you repeat. I should make a table here. Number 1, 2, 3, 4, 5, and this is counts per minute. And then you fill in this table, and you calculate the average. You do the same thing for 1D. So you have 5 runs. This is gamma. This is beta. And you have 5, do the same thing, 5 runs. You fill this in and you do the average. And then we go to part number 2, which is background. Here's your purpose. And then procedure. And then you do 5 runs of it. You set the timer to 2 minutes. Well, I think I apologize. Background is still 1 minute. Well, later on we'll do 2. So it's another table, basically, just like the other one. 1, 2, 3, 4, 5. And this is run, and this is the counts per minute. And then the average. Statistical analysis. It says take 4 more groups. Basically, you have group and run, and we've got run number 1, 2, 3, 4, 5. And group number 1, 2, 3, 4, 5. Now, if you keep the geometry the same as here, you take your hottest source, whichever it is, probably the gamma, but whichever one's the hottest. And you repeat here, whichever one you had there. You could extend this table, but it's probably easier to just repeat this. And here's your mean value, which is the same as the average. So this thing right here is the same as whichever one this was. If you change the geometry of something, then you better just do another new one here. And then you repeat that experiment 5 times. And you calculate the mean value of each one. You calculate the standard deviation. And then you calculate the uncertainty. Then you calculate the mean value for all 25. This is for all 25 of these, the mean value of all those. The standard deviation, sigma, is the standard deviation. This one would be delta, the uncertainty. And you should have learned how to do that type of calculation last semester. If you didn't, then you need to go to your lab book Appendix number 2. It's called error analysis. Okay? And to condense all that into something real short, I'll just point out that the mean value, X bar, in this case would be account bar, or rate, intensity, is equal to the summation of X over the number of counts. Sigma is equal to the square root of the summation of delta X squared over n minus 1. And delta is equal to this sigma over the square root of n. Now I'll go through a real quick exercise to show you how that works. Make a little table. This is a trivial table, but it helps you learn if you're doing it right. This is index I. I'll have to do 5 of them. 1, 2, 3, 4, 5. And just for convenience, we'll play like we get the numbers. 1, 2, 3, 4, 5. This is our experimental values. This is just the run. Run number 1, 2, 3, 4, 5. This is experimental value. In this case, we could say counts if you wanted to. Now then, to calculate X bar is equal to the summation of X over n. The number n in this case is 5. We've got just five values. And so you add all these up. 1 plus 2 plus 3 plus 4 plus 5. We get this is equal to 15 divided by 5. That's the summation of these. I should have another thing. The summation. The summation is 15. And so n equals 5. The X bar is the summation of X over n equals 15 divided by 5 equals 3. So there's our X bar. That's the average value. Delta X is equal to the ninth value, X bar minus X bar. So we can put delta X here. And the difference is 0. This is 1 less. This is minus 2. This is 1. This is 2. 5 minus the 3. 5 minus the average. 5 minus 3 is 2. 4 minus 3 is 1. 3 minus 3 is 0. 2 minus 3 is a minus 1, etc. The sum of those will be 0 because the average deviation is 0. So we square that. Delta X squared. And this is 4, 1, 0, 1, 4. The sum of those is 10. Now we're ready to calculate the sigma. Sigma is equal to the square root. Let me start that over here. Sigma equals the square root of delta X squared over n minus 1. N minus 1 is 4. And that turns out to be something like 1.58, but I'm not sure.
Yes, 1.58.
Okay. So now we've got sigma, and now we get the delta is equal to the sigma divided by the square root of n. So this is equal to 1.58 divided by the square root of 10. That comes out, I believe, 0.707. We round these off to 1 decimal place, so this becomes equal to 0.7. This becomes equal to 1.5 or 1.6. So this, if you do this that way, you're gonna spend all day, you can't afford it. So you get out your calculator. It's been around a long time, and it does not have a standard deviation, an average value. But the modern calculators, what they call the smart calculators, do. This is sample calculation. This is, when you do this analysis over here, you need to analyze. And discuss. Results. Because you should find this thing the same as, you should also do this. You can calculate the mean of this. This right here is for the 25. This is for this whole thing. This is for that. You take the mean value of this, get the standard deviation of this, and it's not going to be the same as each one of these. And then you'll get the uncertainty for this. So this part is for the 25. This part is for the 5. You do these 5 to get that, etc. Then you do these 5, and you can compare these numbers and see how these statistics are fluctuating around one another. 4. So count versus distance, and put the beta. This is for the beta. This is where you do 2-minute counts. So here we go down and we put ourselves in run. 1, 2, 3, 4, 5. And then the 2-minute. And then the counts per minute. And then the corrected count per minute. Now that corrected count, you do this, you get the counts per minute. You do 2 minutes, you get the counts per minute, and you now then subtract off the background count to get the corrected counts per minute. So now you have the corrected counts per minute. You plot the curve of count rate. This is corrected counts per minute versus the distance. So we need the distance up here. Now it depends on where you put these things. Normally, here put it top one, and you do your 5 counts. And the distance, you measure these, I think they're 1 centimeter apart, so this is 1 centimeter away. Then you put it down, now it's at 2 centimeters. And so over here under distance, in centimeters, you have whatever those distances are. You don't have to do it 1, 2, 3, 4, 5. You could get farther down if you want to. You could go 1, 2, etc. So you can do it all the way down here. Any questions on that one? All right. So here you do this, you plot this versus the distance d. So here's the distance d, here's the counts per minute. You have the various distances, and you get dots, whatever it turns out to be. You repeat, and you need distance squared. squared. And here you're plotting D squared. In this case, 5 times 25, so this is 5, 10, 15, 20, 25. And so this first data point, 1 becomes 1, 2 becomes 4, 9, what is that, 4, 16, 25. Just some examples that you could use. And you've got, and so now we're plotting count per minute versus 1 over D. D is 25. So 1 is way out here. Here's 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this first data point would be 1 times 1 way down here. No, the first data point is here. 1 over D is 1/4. That puts us 1/2. Puts us this data point way up here, 1/2 here. Whatever that curve looks like. So those are the 3 curves you plot, and you see if any of them are linear, if any of them kind of. Six, skip, because we don't have an alpha source. 7 is absorption. Beta. And so in this one, you basically take the beta source. You put the beta source somewhere in here. 1, 2, 3, 4. I'm going to put it down this far so I get 5 different. Well, I don't have to put it right. I'll just put it in there. And then I take one of these, I record the value, stick it in, get 2 minutes, and repeat the process. You basically reconstruct this table, except you don't use distance here. You have the run, you have the count for 2 minutes, count per minute, corrected counts, that much is the same. 1, 2, 3, 4, 5. And now you've got to have the thickness in grams per centimeter squared. You've got to look that up, and so you put that in there. This is the thickness in grams per centimeter squared. Then you can plot the count rate versus the absorbed thickness. This is count per minute versus thickness, and this is the thickness, this is the corrected counts. And so you plot that and it does something like maybe that. You repeat this for the log of counts, corrected counts per minute, and versus the thickness. And the log of it will have a tendency to straighten out. It may or may not be a straight line. And then you point, then you analyze, and if one of these is linear, and this may or may not be, but if this one is, if either one is linear, typically it's that one. This is the log, and this is the thickness. If this is linear, then you can get the slope of this. It's minus what's called the absorption coefficient. And then again, you analyze and discuss. Finally, on number 8, you and just repeat. Repeat number 7. Any questions on the experiment?